Hi, Ron. You're with us.
היי, גלית. תודה בעד ההזמנה.
אז רואים שהוא גם מדבר קצת עברית. מאחר וזו שיחה מאוד מאוד מקצועית עכשיו, אז אני אשאל את השאלות בעברית. רון יענה לנו באנגלית. הוא כן מבין, אבל כמובן ברמה המקצועית הוא מעדיף לדבר באנגלית. אבל השאלות שלי יהיו בעברית כדי שככה תוכלו לעקוב אחרי המונחים המקצועיים. אז גם קודם כל לומר תודה רבה ל-Riskthinking.AI על כל הסיוע במהלך כל המחקר המאוד מאוד ארוך הזה, ולהתגמשות שלהם ולתרומה מאוד מאוד גדולה, כי אנחנו שילמנו רק מעט מאוד ממה שזה באמת עלה. מתוך רצון של רון לעזור לנו ולעזור למדינת ישראל להתמודד עם הסיכונים השונים. אז קודם כל באמת תודה רבה רון. Thank you very much for that. טוב, אני אתחיל עם השאלה הראשונה. רון, המודל שלך לא רק מתבסס על נתוני אקלים היסטוריים. הוא כולל תנודתיות, שינויים לא ליניאריים, ומה שאתה מכנה מערכת אקלים לא יציבה. תוכל להסביר לנו מה זה אומר, ולמה כבר לא מספיק להסתמך על ממוצעים מהעבר, במיוחד עבור מדינות שהן יבואניות מזון כמו מדינת ישראל. For you.
So, Galit, that's an excellent and crucial question. What sets our approach at Risk Thinking apart is the fundamental recognition that climate isn't a gentle, predictable progression from the past norms. The past is no longer a reliable prologue to the future. So what we do is we construct probability distributions from all plausible climate futures. And by the way, having listened to the earlier talks, the methodology that we use could even include, geopolitical risks in combination with climate. So this means that we're not betting on one version of the future. We're preparing for inherent uncertainty of it. So why do past averages fail, to guide importers like Israel? For a country like Israel, which relies heavily on imports to meet domestic food demand, understanding the full spectrum of risk is paramount. You can't rely on past averages. It's like driving a car with only looking in the rearview mirror on a road that's constantly changing. When we test our forward-looking data on models, we see how they would perform on black swan events. So in other words, we're looking at forward-looking data, and how do you test that? We take all of the past events that have occurred that are extreme, and then we find actually that we capture 97% of them with data that we developed ahead of those events. So in other words, we can actually capture extreme events before they occur. And that's a pretty hard thing to swallow. We also take a bottom-up approach. In order, for example, to do this study for INSS, we needed to know something like 5 million locations around the world and what could happen in those locations, what hazards could affect them. And that's an enormous amount of data, but that's what you really need to know to really understand the supply chain. I hope that answers your question.
Yeah, thank you. I want to ask you also about the test case and the what we call the תרחישי קיצון. The extreme and those 95%, okay? So I'll ask you about that. התחזיות שהמודל שלך הניב מראות טווח רחב של תרחישים. בחלק מהמדינות הירידות הצפויות בתפוקה הן מתונות, אבל בתרחישים קיצוניים, שזה ה-95% האחוזון, אנחנו רואים אפשרות לקריסה של 30-40%. איך אנחנו יכולים להבין את הפער הזה? האם תרחישי הקצה כאלה באמת סבירים? האם אנחנו בעצם צריכים להתכונן לתרחישי הקיצון, או להתייחס לתרחיש הסביר העתידי?
So, You know, you've hit, this is an important point, but not just for what we're talking about, for in general. That gap that you see between the expected impact and the tail risk is precisely where most of the critical insights for planning lie. If you think even about the war in Israel, you think about what was thought about what could happen, but the extreme case was not taken into account. And look what happened. It's a disaster. So if you measure that tail risk, which has a low probability, but a very high impact, think Israel again, that's what you should be looking at when you look at risk. So while these events are less probable, the potential impact is severe. And let's take some scenarios. If we look at a tail risk for maize that's coming from Brazil to Israel, there's about an 18% decline. And it's about over 16% for wheat from Russia. But even worse, if you look at domestic wheat and how climate can affect domestic wheat production, the drop is about 37% from where it is in the mean. So focusing only on the most likely scenario is like being in an airline and only planning for smooth flights and ignoring the possibility of severe turbulence. It's unexpected high-impact events that truly test a system's resilience. So when you fly back from Palo Alto to Tel Aviv, there's a flight plan, and you follow that flight plan, except you know that there might be events that are unexpected. So that's why you have LiDAR in a plane. You look 1 kilometer ahead, you see the turbulence, and you change direction. So you might be pointing toward Iceland, but you're still going to Israel. So that's the mentality you need to have. There is going to be turbulence. There's going to be events you cannot predict, and you need to be ready for them. And that's a good, once again, think what's happening now. So focusing, you know, on tail risk is the essence of the problem you should be looking at.
I think, or did you would like to mention that if Israel were planned to the extreme event like we had in October 7, probably will face differently than we face it, and that's what you mean when it's not a climate, it's different risks, but according to this, we do have to understand what we have to look at the extreme events and not those tail risks cannot be expected, because for the expected, probably we will not be ready enough.
Think of the situation on October 7th. There were scenarios, maybe by some considered to be unlikely, but they still were feasible, that were ignored. That's ignoring the tail. That's a bet you're taking. You're taking an out-and-out bet it's not going to happen. But if you measure that bet against the consequence of being wrong, i.e., if you were wrong on October 7th, what is the result that would have occurred, and how big is that? And if you think of it that way, a tiny probability with a big outcome is still something you should be looking at and dealing with. But what we took was an out-and-out bet. So it's irresponsible not to plan around such extremities. It's not just nice, it's irresponsible if you do not. And focusing solely on the most likely scenario provides a false sense of security. The real vulnerability occurs when the system responds to a shock. And understanding tail risk allows policymakers to identify critical vulnerabilities and make informed decisions about diversification, stockpiling, or even domestic capacity. So it's really understanding that tail risk and understanding the bets you take, not just the risk you're measuring. knowing your bets is as important as knowing your risks.
Thank you. So the last question I would like to ask you is about your model. So המודל שלך מציג תמונה מאוד מורכבת, סיכונים שונים לפי גידול, מדינה ורמות הסתברות, שכולם משתנים לאורך זמן. זה בהחלט משקף את המציאות, אבל יוצר קושי אמיתי בקבלת החלטות. במערכת כל כך לא ודאית, איך אתה מציע שמתכנני מערכת המזון, ונמצאים איתנו כאן גם משרד הכלכלה, גם משרד החקלאות, גם משרד האוצר, גם משרד החוץ, מה הם, במיוחד בישראל, איך הם יעבדו עם הנתונים, איך הם יעברו מנתונים לפעולה?
So you're right, the picture is complex, but bad luck, the complexity is the reality. You get in a car, which is a very complex machine every day, but you don't need to know a lot about what's going on in the engine. You know how to drive it. So the irony is, in a very complex situation, and if you model it appropriately, the tools you use can actually be quite simple. And we show that with our tool Velo, for example. So I would certainly encourage that you embrace the probabilistic nature of the problem. If you make projections about the future, they are not going to happen. There's no way you can predict what's going to happen in 2035 in Israel. Nevertheless, even to predict what will happen between October 6th and October 9th, you need to look at it from a purely probabilistic point of view. So the first step is to move away from seeking simple, single deterministic forecasts, and instead embrace the probabilistic insights. And our analysis provides not just an average expectation, where everybody's looking actually, but a spectrum of possibilities. So you should expect that the output does look complex. It is a distribution, it's not a number. And that's exactly the nature of what's called a radically uncertain problem. And climate change and geopolitical risk is a radically uncertain problem. So, there's a lot you can do, even with knowing all that. So, for example, when you look at diversification of trading partners, it's not just about adding more countries, it's about strategic diversification. The data, for example, shows how Israel can identify suppliers that have lower extreme risk, lower tail risk. And maybe you need to include those people, even though they might be more expensive. It means also exploring new markets where climate risk profiles are uncorrelated with current suppliers. Different regional climate systems like El Nino and monsoons, it's complex, but you can manage it. And it's not about knowing the risk, it's about how you manage it. So strategic stockpiling, which is the first thing that comes to mind, can help you buffer against short-term disruptions, but it's not going to solve your problem. And once again, this brings us to tail risk. If maize from a key supplier is making up 20% of imports and has a 15% tail risk, you really, really need to be concerned about it. And this is particularly relevant for grains from high-risk partners where tail risk can exceed 20% from China, for example. And, this also applies to domestic capacity. If you expand domestic production, it seems intuitive, but our analysis offers crucial insight that Israel appears to face substantially higher climate risks, tail risks for its domestic maize, something like a 40% loss in production compared to key imported resources. So, there is a systematic way you can go about things if you do it taking full probabilistic nature of the problem into account. So as you said in your talk, this isn't a one-time assessment we should be doing this all the time. The climate's changing, the geopolitical situation's changing, they are integrated, they are related. There's agricultural practices, there's technology on water planning and so on. We need to integrate this type of forward-looking risk assessment into an ongoing monitoring and adaptive management framework. As I hoped when we spoke, I hope this is not the end, it's just the beginning of what you're doing in Israel to manage these extreme risks.